Thank you. Right, 5 dogs, A, B, C, D and E. I like that about dog names. That's what all dogs should be named. Let's do that then. Took part in 3 races. The order in which they finished the first race was A, B, C, D, E. How convenient. Spearman's rank correlation coefficient between the orders for the 5 dogs in the first 2 races was found to be -1. Write down the order in which the dogs finished the second race. Well, if it's -1, that means that the rankings were completely opposite. So if the first race was A, B, C, D, E, the second race must have been the complete reverse of that. So E, D, C, B, A. Right. Sounds like John has stopped, yeah. Oh, that's on the video now. Right. Part 2. Spearman's, should we close the door? Spearman's rank correlation coefficient between the orders of the 5 dogs in the first race and the third race was found to be 0.9. Show that in the usual notation, sigma d squared equals 2. This is great, isn't it? So this is kind of turning Spearman's rank completely on its head and giving it a nightmare. Right. Spearman's rank was 0.9. So that means 1 minus 6 sigma d squared over n times n squared minus 1 was equal to 0.9. Except it's not quite that, is it? Because we know a little bit more than that. We know that there are 5 dogs involved in this whole situation. So n was 5. So actually I should have written 1 minus 6 sigma d squared over 5 times 24 is equal to 0.9. And now it's just, well, again, in this paper that's supposed to be all about stats when we're doing lots of algebra. So again, it's a kind of core 1, core 2 algebra thing. We've got 1 minus, well, what is this? 6. 6 over 5 times 24 is 1 over 20. That might not be right. It might be right. I do feel happy it's right. Is it right? Yeah. Good. Yeah, because 6 cancels 24 to give us 4 on the bottom of 5 4. Yeah, good. Right. So we've got that. If we rearrange the algebra that we've got here, we've got 1 minus 0.9 is sigma d squared over 20. 1 minus 0.9 is 0.1. And if we do 0.1 times 20, we get sigma d squared is 2, which is what we were supposed to get. It looks frightening when we first read it, but actually it was a fairly simple bit of algebra to work through that and get to that. Now, part 3. Hence or otherwise find a possible order in which the dogs could have finished the third race. Okay, so sigma d squared had to be equal to 2. 2 isn't a square number, so the only way we can get to by adding square numbers together is by 1 plus 1. Okay? So 2 of the values must have been 1 as we added them up. So if we think about the dogs, they're the dogs. In the first race, it's the first and third races that we're looking at. Yeah. So in the first race, they were in that order. The third race, what we need to end up with is the sum of our differences squared had to come to 2. Now I think that would work if it was 0 for 3 of them, and then the other 2 were swapped round. So if those 2 dogs had finished in the other position, we would have, what would we have? This is the d column, this is the d squared column, so we would have minus 1 and 1, and so that's 0, 0, 0, 1, 1, giving us the sum as being 2. So the order that we could have, one possible order, is A, B, C, E, D. But can we see actually all we need is any order like that where you've swapped 2 of the numbers round. That's all that we need to happen. and that would be the right. So the first two being opposite way around the work. And that's maths.